Now that we've discussed the idea of simplifying a trigonometric expression, we're going to look at something called actually verifying or proving trigonometric identities. So we were calling the things that we started with the fundamental identities. And you may have noticed in the last examples, all the simplifications basically came out to the same thing. That's not exactly a coincidence. It turns out that a lot of different trig expressions may start out looking totally different from each other, but when we get done simplifying them, they all look like the same thing. And so when we can see that two trig expressions are the same in some way, then we know that they're actually equal to each other. And we have something that's called an identity. The key thing to keep in mind about what we're about to do with a so-called identity, an identity looks like an equation. It's going to have an equal symbol, but we're not solving. We're going to show that it's an equation that has two sides that are always equal to each other. That's the key defining characteristic of an identity, an equation that has two sides that are always equal to each other. So our goal is to show that this is the case. We won't know from the start that the two are equal to each other. That'll be our goal in the whole thing of this verifying or proving process, showing that they are always equal to each other. So let's start out with an example. It's going to look something like we have cosine theta times secant theta minus cosine theta, and it says here equal to sine squared theta. Okay, so the goal again is to show that these two are actually equal to each other. We're not trying to solve. We're just trying to show that the two are equal to each other. So the few things we can do to make this happen. One of the key things is we're going to work each side separate from each other. Okay, then ensure that we're not assuming that the two are equal from the very beginning. So we're going to work each side separately. The goal of doing this is to show each side is equal to the same thing. Much like we had noticed in the simplifying examples when they came out to be the same thing. So the rule of thumb here, this doesn't happen all of the time, and I'll show you some examples where this rule of thumb we kind of have to deviate from it. But the basic rule of thumb, just like we were dealing with trig expressions, is to write everything in sine and cosine to get started at least. Okay, so this is the basic idea. If you need to take note of anything I have here, you can always pause the video, and when I come back, I'll go ahead and start working on this one. So the idea, working each side separately, let's label this LHS, this stands for left-hand side, and let's call this RHS for right-hand side. Okay, so the right-hand side is just sine squared theta. Okay, now I'm just going to leave that as is. There's nothing really to do with it since it's already just the sine itself. So let's keep that as is for now and look at the left-hand side. The left-hand side has a lot more going on with it. So we usually will always start with the side that has more stuff going on. The more complicated side is kind of another rule of thumb. But we can write this one in sines and convert over into sine and cosine. Particularly the secant. Let's start off with the secant here. We're going to change that over to 1 over cosine theta. So it looks something like this. Now notice that we can start at this point to distribute the cosine in the front of the parentheses into the inside of the parentheses. When we do that, it's going to make it look like cosine theta over cosine theta minus cosine squared theta, which this whole thing here is just going to simplify down to be 1, so 1 minus cosine squared theta. And if we looked at the example from when we were simplifying, I mentioned that we had an identity basically that says that sine squared theta is equal to 1 minus cosine squared theta. So what that means is this is equal to just sine squared theta. And so now we see that we have the right hand side and the left hand side both equal to the same thing. So thus we know the right hand or the left hand side equals the right hand side, and the identity is proven or verified.